Hi there. In this video, we're going to talk about the Heaviside Unit Step Function. So this is a very useful function. What it does is that it switches on or switches off a particular term inside an expression. And this is perhaps modeled in reality to represent events that start at a certain time. For example, if we think about the sudden application of a force, if we think about when we switch on the power supply in the circuit and current starts flowing, if we think about the sudden spill of a pollutant, if we think about some economic event that has just occurred and there's some market response. So it's very often the case that we want to start showing a response after a certain time when something happens. So this Heaviside Unit Step Function is something that can actually do that. So how it actually looks like is that we have our unit step. We have time and we have some function of time. And when time is equal to c, then that's where we have our unit step occurring. So we can say that this function of t is equal to 0 for t less than c. So when t is less than c, we can see 0. And then f of t is equal to 1 for t more than equal to c. So we can let this Heaviside unit step function take on any value actually, but just how we represent it. So how we represent it is by, we can say f of t is equal to u. So this u is meaning u as unit function of t, or rather unit step function or something like that, but u designates a function. And we'll say u as a function of t minus c. So this is how we write the unit step function. So when we say this expression here, we're meaning that it is a unit step is being applied at a certain point. So this constant c, this c is a very important parameter because it tells you where exactly this unit step starts. So if c was equal to 4, it means that we'll have u into t minus 4. So it means that this c will take on the value 4. And we can actually now not just restrict ourselves to the value 1, but it can be any value. Okay, it can be any value. How we would do it is that we would just multiply this u as some function here by whatever value we wanted to. For example, if we wanted, instead of 1 as the unit step, we wanted it to be 3, then we would just multiply it by 3, and it would take on the value 3. So 3 times this u as a function of t minus 4 is the unit step that starts at when t is equal to 4 and takes on the value 3 beyond that point. So it doesn't need to be a constant like 3. It can be anything. If we multiply it by a function, it means that beyond this point we will have a function. So how does this actually work now when it comes to functions? How would we represent it? Well, we can take a basic illustration of a parabola. So there's a parabola that we have, and a parabola is given by the equation f of t is equal to t squared. So what we want to do is we want to restrict this function, we want to suppress this function, and we only want the function to start basically when t is equal to 2. So everywhere else we want the function to take on the value 0, and then at t is equal to 2, we want the function to carry on at that point there. So all we would do is we would apply our function as we have just described, this value c, and in this case here on the top it was 4, so we would just substitute where we want the function to actually start, and we would carry on in that manner. So what we would do is that we would say that f of t is equal to t squared, because that's the value we want to take, and then we would now multiply it by our Heaviside unit step function, so that's t minus 2. So when we represent it like this, we're saying that the function will be 0 everywhere else except at 2 and carry on as it normally is. And what that actually looks like is this. We can see that when we write it, we can just write it again. We have f of t is equal to t squared times u into t minus 2. We can see that it's taken on the value t squared, but only where t is greater than or equal to 2. So this function u actually makes that happen. So when t is less than 2, then this unit step function, basically ut minus 2, what happens is that we have t squared times 0, because this unit step function is equal to 0, and that gives us 0. And now when t is more than or equal to 2, then this unit step function, t minus 2, u and t minus 2, we have t squared times 1, and that is t squared. We can see how beyond this point, it takes on the value t squared. So we can just look at one more example, and that example is if we want to switch on and switch off a particular function. So this is the function of f of t is equal to e to the minus t. So that's t, and that is f of t. And now what we want to do is we have a certain value 2 and a certain value 4, and we want to say that we only want this function to take on this value e to the minus t between 2 and 4. So we want to suppress this function everywhere else. So how we would do it is, firstly, we would apply our unit step function. We would say f of t is equal to e to the minus t, and then we would multiply it by u into t minus 2. So that would actually mean that the function would now only start beyond 2. And now we want to also remove everything beyond 4. So how would we do that? What we would do is we would just apply this unit step function again, but we would change the sign. So we would say minus e to the minus t multiplied by u into t minus 4. So this negative sign is the thing that actually makes it happen. So what it does is that it says that it's valid less than 4, and beyond 4 there wouldn't be any value. It would be 0. So between 2 and 4, we essentially have 0. So, outside of 2 and outside of 4, we have 0. And between 2 and 4, we have our function being e to the minus t. So this is an illustration of how we can have the Heaviside unit step function as a means by which we can manipulate and suppress functions in certain regions, and we can represent the onset of some event, which will allow us to model and represent events in reality. Thank you very much.